On my 2000 Chevrolet pickup, this truck has 4 O2 sensors, 2 upstream and 2 downstream. Now the 2 downstream measure Cadillac performance, where the 2 upstream actually monitors the fuel mixture. The code I have today is for Bank 2 Sensor 2 downstream heater performance. Whether it be upstream or downstream, these sensors are all tested the same way. So I'm going to be testing the downstream passenger side O2 sensor. You can test any of the other 4 the same way I'm testing this one. Now before you buy any parts, you're going to need whether this vehicle was built in Canada or the United States. By looking at our VIN number located either on the windshield or on the door, this is how you'll determine whether it is a US or a Canada built vehicle. The first digit of the VIN, which mine you can see is 1, that stands for built in the US. Now Canada will have the first digit to be a 2. Now what I have at this time, I've got a check engine light, code P0161, heater performance, Bank 2, Sensor 2. Now Bank 2 is going to be on our passenger side, Bank 1 is going to be on our driver's side. Now this is located downstream, post CAT, so it's after the catalytic converter. Now I always like to check for a TSB. In this situation there is no TSB, but a TSB, technical service bulletin, can be a time saver. It's like having your headlights not working and you're not checking the fuses first. We've all done it. I've checked the TSBs, we're all good there. Now our probable causes, O2 sensor fuse, or the powertrain control module, PCM. Now by looking at the schematics, we know I'm only having an issue with one, as well if you only have an issue with one. Now our upstream O2 sensor heater fuse, if it's blown, you're going to have both heaters showing a problem. Downstream has a different fuse, which controls the 2 downstream heaters. And since I only have one, then I know I don't have a fuse problem. Now, if you have 2 downstream sensors not cooperating, then you want to check to see if the fuses is good. Now, in this video, we're going to go ahead and I'll show you where the fuses are and we'll check them. But just by knowing that I have one sensor bad, I know my fuses is good. Now, back to our wiring diagram. If we'll look, all 4 sensors share the same ground. That tells me that most likely it's not a ground. Now, it can be the wire is broke between the sensor and the grounding point, but that's highly unlikely. Either way, we are going to check and make sure we've got a good ground. While we're looking at the wiring diagram, if you'll notice, the PCM actually never connects to the heater. The PCM determines this by how much time it actually takes to get a good reading off the sensor. For example, outside temperature, run time plus heat equals a good or a bad sensor. Now we are going to check all the pins and give you the information that you'll need to diagnose your O2 sensor. What I've done is took scan tool readings off of both of my lower downstream O2 sensors and compared the 2, and I've done that for cold to warm up. And if you'll see static with just the switch on, the big difference between this sensor, our downstream Bank 2 sensor, than all the rest of the sensors, which was a good starting point of a comparison. We still don't know if it may be a connection here. Here's our downstream O2 sensor, which we're in suspect of, and here's our harness connector, and it still could have issues there. But as I let the engine warm up, it come up, but it didn't really follow the same as the opposing side, and that's, I was just comparing the 2, and that's a good starting point if you've got a scan tool, and it's just a basic scan tool is all you got to have to read the 2 sides. So I'm comparing all 4 of them, and then I'm comparing the 2 sides. Now after that, what I've done is I ordered me a aftermarket. It was a Denso, which I work for Toyota, and Denso is a good name, and I installed it. And what I had found is from static cold start that it was way low. Big difference in the reading. And as it warmed up, it come up to a normal reading and then it fell off. If you'll look, I'll show you in this scan tool reading. So I still wasn't satisfied with either it's maybe my harness or it may be the ECM, but something is not right. So I decided to now both these downstream sensors are the same part number, so I decided to swap the 2. I'll show you those readings next. And if you look, you'll see that everything swapped sides. We've actually got a lower reading on sensor 2 than we did when we had it on the opposite side. That's kind of strange, but let's let the engine run for a little while and let it warm up. Let's see what actually does occur. I don't think that the check engine light will set in this mode anyway, so we'll let it run, and let's look at the scan tool readings as it gets hot. You'll look at the scan tool readings, we'll go over them. Now another thing to consider, if you'll watch our upstream sensors compared to our downstream sensors, because you think about it, our upstream sensors is actually moving from rich to lean like they're supposed to, and they're not sluggish. If you'll notice, the downstream sensors mimic that. And the reason is our cats is not hot. Once our cats heat up, the downstream sensors will stabilize and they'll fluctuate just a little. But if you get that after your engine has been run and it's hot, and you still get a heavy fluctuation, kind of mimicking our front sensors, then you got a bad cat. Now look at the numbers on bank 1, sensor 2. See how sluggish it is, and it's holding a little high, but it's not able to get down below like bank 2, sensor 2 is doing. Just by comparison, that right there tells me that that sensor is definitely bad. Now, even though the engine is not hot, this is what it would look like if you had a bad cat. Well, that in itself tells me that that sensor is bad. I would feel totally comfortable with swapping it out and not worry about having it come back as an issue. So what I've done is I've swapped these two sensors. So I've moved this sensor to bank 1 and moved this sensor to bank 2. And you'll notice that actually everything swapped. Look at these numbers here, how they just stay the same, where this is starting to fluctuate and eventually gets higher. Now let's look at the sensors as the cats is warmed up. If you'll notice, both the readings is up there and they're kind of stable. They move back and forth just slightly, and that's what they're supposed to do. Now the ECM will determine that the cats are good on account of that. Now you may get a check engine light intermittently where you drive it one day, check engine light comes on, then the next day you drive it, or the next couple of days you drive it, and it goes back off. So if you have a light, check engine light that's coming on and going off, this may be your problem. If you've got a code for the heater circuit or for a downstream O2 sensor, this very well could be the cause of it. The sensor is sluggish, and even though after it got hot, it come up to a good number, that doesn't mean that it's a good sensor, and you'll probably get a check engine light later on. I got an AC Delco part number that's supposed to be fitting this side. And we're going to install it, cold start, same conditions, and see what it looks like. I'll show you where all 4 sensors is located. Now this is bank 1, and our first sensor comes before the cat. Right here's our cat, comes out before a cat. So that's bank 1, sensor 1. And then we come down just past the cat. This is bank 1, sensor 2. Downstream, sensor 2. On the opposing side, the side that we're concerned with, our bank 1 sensor is up before the bin, and of course before the cat, so it's a pre-cat sensor. And then our downstream or post-cat is just before it gets to the Y where these two connect. If you'll notice right here, this one comes down over and goes to the other side. Now our connector for the left side is mounted right here, and you'll have to pop it up to disconnect it. But I do not suggest you do that. One thing is these gaskets. If you look at these gaskets, they're crush type gasket. And once you crush them, they're crushed, so you can't reuse them, because the sensor is really made to just be installed one time. Now with all that being said, here's what I'm talking about on our gasket. If you look, what it does, it's a crush washer, and then it seals up the exhaust. But with all that being said, I have replaced several catalytic converters, reused the old O2 sensors and never had a leak and never had an issue with one coming loose. I just want you to be aware of what's happening, and if it's got some age on it, you go to take it off, you may mess up your threads. Like this one we know is bad, so it's got to come out. But if you try to swap them back and forth, you might damage the other side. That's all I'm saying is, so be cautious. Now, first thing I want to do is I want to check my system voltage, so I want to know what the battery is. And we're going to set our scale to a 20 volt scale. And we want the positive on the positive or on the red side and the negative on the negative. That way you don't have that minus on your meter. Now we want our switch on because the heater circuit don't work until the switch is turned on. Then we'll check our fuses. Now if you notice right now we've got what, 1198. When I turn my switch on, it's going to drop our system voltage. So we want our system voltage with the switch on. So this reading is really not good until you turn your switch on. Now with our switch on, we're showing about 11.5. Now we can check our fuses and see what our voltage is at them. Now we're going to take our positive side off our battery and we're going to check the two 15 amp blade fuses. We want to check both sides. Okay, we got 1142, 1142, 1142, 1142. Now, you're not going to get the same voltage as you did at the battery because of voltage drop. But we're allowed up to 0.2 volts drop and the system still operate fine. So in order to do a voltage drop, we're going to take and put our red lead back onto our positive. We're showing about 11.5. We're going to take our ground lead and we're going to put it on either one of the fuses and say we got 0.08. Now in the event you do have a fuse blown and you have corresponding sensors, either upstream or downstream sensor fuses blown, you have a code for both either up or downstream sensors. Then what you can do is you go and unplug both sensors and see if your fuse still blows. Now if your fuse still blows, then you've got to short the ground. If not, then one of your two sensors is pulling too many amps and you'll have to check that with your meter. Now we're back down to the bottom. We want our meter to be on 20 volt scale. And we should be getting around system voltage 11.5. We're 11.23, which is okay. Because you got to remember, now if you're getting a real low voltage here, that your battery may be starting to drain. So don't condemn this until you know for sure your battery is low because we're not running the engine. You can run the engine, I'm just not because of the sound and the heat, and then you'll get something probably 13 volts. We've got, now if you have a failing battery or something like that and your voltage is dropping too quick and you do have to run the engine, just be aware that with this connector disconnected that you're probably going to get some other codes. So we won't worry about them. We're going to clear all the codes when we get ready to drive it anyway. Our system voltage, we've got a reference voltage. That's the high reference voltage. And then here's our low reference voltage. This other one's going to be a ground. Now we're going to move over to the other side and I'll show you it's exactly the same thing. Here's our pigtail. We're going to reference it the same way. It flips up. And we know that's ground. This is going to be our system voltage. It's reading about the same as the other. You can compare the two. You'll know that's good. we're going to have our high and then our low. Okay, now we'll lower the truck, turn the switch off, and then we'll check resistance for our ground. Let me explain what I was talking about with the meter and how much resistance we started out with. If you look, let's take a look at this setup. Now you see all the harness and the connectors I've got. Every time you add a connector, every connector is going to have some resistance. Depends on how long the wire is, it's going to have some resistance. So we'll take and we'll check our resistance through the whole circuit. We'll let it settle down a little. We're running around 2, 3. We take that off the 6, 7. We're under our 5. And that's all I'm getting at. So we started out with 3. We've got to take that off our total resistance. Now let's not get all hung up on resistance anyway. The battery's not been disconnected and the ground may be shared by other things that's getting a small amount of power. So if we're under 5 total, I mean after we take off our 3, 4 there, we're under 5, we're good. If we're above 5 slightly, I won't condemn that circuit. I won't say it's got a bad ground. It's going to have to be really stepping up there into maybe 1, 2 ohms. Now with our switch off, again, we're going to go to our lowest scale on our resistance, and we're going to check. See, we're at 0.7, which as long as we're at 0.5 or below, we're good. But the meter has anywhere from 3 to 4, so we're actually probably running 2 or 3. So we're actually good. Now you can go to the other side and check it exactly the same way. What I've done is I've swapped the sensors back, or I pulled the bad one out, and then I put the good one back where it was to begin with. Now we can take and we'll run us an ohms test. As always, we're going to put our meter on our lowest scale. And if you look at the orientation, these 2 connectors, now usually a replacement is usually black. If you'll see, these wires are black. That's usually the heater circuit. Most of the time, that's going to be the heater circuit, and it's going to have the same colored wires. These are brown. And my old sensor, we're getting 4.5 ohms resistance. Now let's move it over to the new one and let's see what we get. Looks like 15 ohms resistance. So with a little voltage, most likely this sensor is opening up. Now with that, I want to show you this too. Now if you look, this sensor has openings. See, that looks like it's little filters is what it is. And it actually takes fresh air from the outside and it compares the difference in the 2, and that's where it gets its reading from. There's a difference between our factory one that is 20 years old compared to our new one. This one I see only has one place right there. You might be able to see it. I don't know. So what's happening is the outside air is getting pulled through here, and we've got exhaust air coming through there. The difference between the 2 O2 mixtures produce a voltage. The smaller amount of O2 here, larger amount of O2 here is going to produce a higher voltage, which is going to interpret that as a rich mixture. And as the O2 count gets closer, this produces less voltage, so it's going to interpret that as a lean mixture. So if you've got fresh air coming in here where you don't have a good seal, that's going to bring our O2 count higher here. This is not going to produce the voltage it needs. The ECM is going to think that it's being a lean mixture, so we want to make sure there's no exhaust leak around this area, and this is not stopped up. And here is our part number. It's a AFS 106, which is the GM part number is 1935-5306. Now we'll go through our steps and reinstall this one. Now this does come with some anti-seize, so we're going to put a little bit on there. We're not going to just go goop it down, and we don't want to get it into this, so we're just going to keep it in our threads. It's got a little opening here. We'll tear it open. And what I like to do is just put just some on the threads in a couple of spots, because like I said, we don't want it actually in them holes. All right, and we'll reinstall it. First you'll feel, see our washer, you'll feel it starting to crush. Felt it crush in. And I'll feel it stop. That should be more than enough to take care of it. Now in this video, you probably have more questions than you do answers. I feel like that as a professional technician, we sometimes forget what lesser experienced people actually need to know. Now I hope this will give you a reason to give me some kind of feedback so I can see what I'm missing that you actually need to know about. There's several things I'm going to do more on the O2 sensor on what we should see, and then we're going to go in the repair manual and see how GM says to test this circuit. So if you can give me some feedback on this, I welcome all that you can give me, and then maybe in the next video we can go ahead and decide what y'all really need to know. I'm James Noble. Thank you for watching.